Now our topic is electromagnetic induction. Electromagnetic induction is completely opposite to that whenever current is flowing, we are getting magnetic field because of that current, but here we are getting current because of magnetic field. So totally reverse of that process. So electromagnetic induction. Now first demonstration for that, if we are having one solenoid, that solenoid we have to connect with here one galvanometer, right? One key will be there. Key is not compulsory needed here, but we have just put that key to complete this circuit. Now here I am having one bar magnet, north and south. Now what I am doing, this bar magnet with v velocity I just bring towards this coil, this solenoid. So as fast as I can, if I move this bar magnet towards this coil, there will be deflection of this in this galvanometer. But if I just put at rest of in bar magnet, there will be no deflection here. And the third thing, whenever I just keep this bar magnet with same velocity, but it is now away from this coil, then this galvanometer just deflected opposite to that earlier, with that earlier. So if earlier we are having galvanometer right hand side deflection, but because of this bar magnet, now it is moving away from this coil. Now galvanometer deflected towards left hand side, so completely opposite to that galvanometer deflection which we get earlier, right? So that means actually what happens here, because whenever I just keep this bar magnet which is moving towards this solenoid, this magnetic field lines link with this solenoid. Whenever magnetic field lines link with this solenoid, we are having magnetic flux, but that magnetic flux is not constant, it is varying magnetic flux due to we are just keep this bar magnet which is going towards this solenoid. So magnetic flux is keep increasing, right? Because here velocity is v, so magnetic flux is just keep increasing. Because of that varying magnetic flux, we are getting induced EMF all over the circuit, and induced EMF just create induced current in the circuit, and that's why we are getting this galvanometer which is deflected then. So that is first phenomenon. Why we get current here? Because relative motion between coil and this bar magnet, if both are moving in same direction with same speed, then there will be not any deflection here. So relative motion will be zero if they are moving, both are moving in same direction with same speed. So one has to be in rest and one have to move. So this is how we are getting current, or otherwise one has to move in this direction and one has to move in opposite to that direction. So again we are getting current from this circuit. So that is first demonstration. Now second demonstration, we are having one more number of coils. That solenoid should be connected with one battery and a key, and further we are having second coil which is connected with one galvanometer, right? So now what are we doing? Now current is passing through this coil. As a result, we are getting magnetic field which is linked with this circuit. So magnetic field will be produced because of this circuit, because here we are getting magnetic field because of current is produced here. So current is flowing, magnetic field will be produced, and because of that magnetic field will be linked with this coil. So see, not constant current gives us EMF here, only varying current. Why varying current? Because of varying current we are getting varying magnetic field lines, and because of varying magnetic field lines we are getting varying magnetic flux, and that varying magnetic flux induced EMF in this coil, and because of induced EMF, that induced EMF create current throughout this coil, and that's why, and at that time galvanometer will be deflected. So that is the first way to get galvanometer deflected. Second way, now if current is constant, so current is constant, no deflection here. But if I just move this coil farther and nearer, then because of that change in magnetic flux, now again we are getting galvanometer deflected. If that coil will getting nearer to this coil, then galvanometer deflected right hand side. But if it will be moving away from this coil, then galvanometer deflected right hand side, opposite to that earlier deflection. So how can we find motion direction or field direction or current direction? So earlier we discussed that Flamingo's left hand rule, but now we can find these all three directions, but three direction not simultaneously. If we are having two direction, then we can find third direction, right? So by using the right hand rule, right? So right hand rule, first finger just is representation of field direction, this north south field direction. Second finger represent current direction, induced current direction, and thumb represent motion direction. So here motion in this direction, so I have to place that thumb in that direction, right? Current, we know that that is representation of second finger, and field is representation of first finger. So this is how we can find the direction of current or motion or force or field direction. So that is our electromagnetic induction.